What's up everyone, my name is Vindrake from catscozygames. In today's tutorial, we're going to go over the construction and automation of the LGT, also known as the Large Gas Turbine. We'll go over which turbine blades to use, and how to configure it to consume just the right amount of benzene, and also turn it on and off as needed, so you don't waste any of that precious benzene or power. So without further ado, let's get into it. Alright, first things first, we're going to assume that you already have a Lapotronic Supercapacitor to store energy. Now, you don't have to have this. You could use an insane voltage battery buffer if you're an IV by this time, and you could throw a bunch of Lapotronic energy orbs into this. But really, by this time, you should be able to afford a Lapotronic Supercapacitor with IV capacitors inside. And as you can see, if we turn this on, total capacity 10 billion EU. That should be plenty for the stage of the game. And basically, we're going to give this power, and then we're going to detect the power on this and control our large gas turbines via Redstone, tell them when to turn on and off, because it's very important you decide on a lower bound of energy to turn them on, and then a higher bound of energy stored to turn them off. That's basically how we're going to work this. So first things first, I got a bunch of goodies over here. This is basically what you're going to need. You're going to need to build the large gas turbine, which we'll do in a second. I'll show you how to do that. And then you're going to need a bunch of machine controller covers, fluid regulators, ME dual interface, some IV cable, some LUV cable as well. We're actually going to transform into LUV amps because that is better on loss per block, EU packet loss. You'll need some transformers, IV transformers. We're also going to put an IV 64 amp energy hatch on our LSC, our Lapotronic Supercapacitor, and an IV 64 amp dynamo hatch as well. You're going to need a bunch of redstone things here. These right here, these wireless transmitters and receivers from our WRCBE logic, these are very, very handy. Not too difficult to craft. Energy detector cover to detect our lower and higher bound of energy stored. Some LV dynamo hatches just as a sort of a dummy block. I'll show you how that works in a second. And some other redstone stuff. We'll go over all this as we get into it, but let's go ahead and put together our LGT initially. And you'll be put together a bunch of these, by the way, so we're just going to do one, but yeah, you'll put together a bunch. So put this together. It's a 4x4x3 block, and it's very, very specific about where its hatches and such go, and I'll show you that in a second. Basically, these areas that I've left are the only places that you're going to put any kind of like maintenance hatch, muffler hatch, etc. So I'm going to put the maintenance hatch right here, muffler hatch right there. And then we're going to do, actually, I need an input hatch. Usually an LV1 is sufficient. You don't actually need that much fluid storage inside here, so 16,000 liters is plenty, because you ideally don't want to leave a bunch of benzene in here, because you'll actually waste the benzene when you turn on the turbine initially. And so we're going to stainless steel turbine casing. By the way, make sure that you use stainless steel turbine casing specifically. Don't use the clean stainless steel machine casing, because it's a very common mistake. I made it myself, and yeah, this will definitely not work. It's a very specific type of casing. Looks exactly the same as the clean stainless steel, but it's definitely not. And the final thing that you want to put in here, if you look up dynamo hatches, there's a particular type that's called, let's see if I can find it. Let's type in buffered. Yeah, there's a particular type of dynamo hatch called buffered. This is the type that you want to complete the multi-block. And you'll get, you'll see amperage down there. It says 4 amps. So ours will be capable of, and we're going to use an EV dynamo buffered hatch. This will be capable of 4 amps output of EV. And then we're going to transform that to IV and then LUV as well. Recently, my wife Kat and I live streamed ourselves putting together this exact setup. If you're interested in catching more of our live streams, we stream every Monday through Thursday at 1 p.m. Eastern. We're live on all the streaming sites, YouTube, Twitch, and Kick. We hope to see you there. Alright, I've set up a little ME system. We have some benzene right here. And so what I'm going to do is I'm going to just do some wireless connectors. You may not be able to afford these as often, but it's just a way of transporting applied energistics cable around. So we are going to connect those together. And then I'm going to grab some covers over here. Let's grab a bunch of this stuff right here. And let's see. What are we going to do first? I'm going to put a machine controller cover down here. You'll see why in just a second. on the bottom of this. We're also going to place one on the bottom of the actual controller block in the middle here itself. And this is how we're going to control with Redstone. And so what we're going to do next is put a fluid regulator on the middle face of this input hatch. You can right click like so. And let's go ahead and get in here. So there are very specific values that you need to put in order to get this to work. Now I'm going to link a spreadsheet in the description of this video and the comments below. And you're going to use that basically based on which turbine blade you decide to use. You're actually going to put a different amount here. So I'm going to go with Ori Huracan large turbine blade. And that's going to be negative 13 liters per second, exactly. So each turbine blade will have a different value. And yeah, let me show you exactly how to use this spreadsheet. All right, so I've navigated to the quick links GTNH wiki page. This is actually a very, very good resource for a lot of different documentation for a lot of different parts of GTNH. We're going to go down here to turbines, and you're going to click on the version number of GTNH that you're currently using. We're using above 2.7.0 right now, so we're going to click on that. You're going to get this big spreadsheet. Looks very complicated. It's actually very simple. We're going to walk you through it. You're going to go up here to File, and you're going to make a copy. And the reason you want to do that is you want to be able to change these values, and you're not going to be able to do that in that current iteration. You want your own copy of the spreadsheet, essentially. All right, so here we go. We've got our own copy now. What I'm going to do is I'm going to go over here to the turbine selector, top left. And as you can see, there's a bunch of different materials that you can choose from. You can play around with this some. I would recommend that you do that. But we're going to go ahead and go with Ori Huracan. We're going to click that. We're going to click the rotor size. You generally want large rotor, although again, this is something that you can play around with. And then the area that we are concerned with is this large gas turbine area that I'm highlighting. So everything else, don't worry about it. You're going to come over here, and most of this will actually already be filled out for you. You want the type mode right here at the top. Fuel type benzene. If you're using something else, then make sure you click the proper fuel type. And basically, it's going to tell you the dynamo output in terms of EV. Now you can change this to IV or whatever you need to, but we're going to go with EV, and it's 3.542 amps. And so about 4 amps of EV, which is, you know, we'll just consider it 4 amps essentially. But this number right here is the magic number. This is the number that you want on your fluid regulator on the input hatch of your LGT. This will be the same for all your LGTs. You know, you basically want to replicate this setup multiple times. So let's get back into Minecraft. Alright, so we got our fluid regulator at negative 13 liters per 1 tick. Make sure that you do this, the use processing machine state, the conditional. You want this to be the middle button right here. This is what's going to allow us to turn on and off the flow whenever we want to turn the machine on, essentially. So we're going to do that. And let me go ahead and find Ori Huracan. Let's go ahead and get our turbine blade real quick. It's this right here, Ori Huracan turbine blade. We'll hit the uses of that, go to assembler, and here's your small, regular size, large, and huge turbine. We're going to go with huge. Let me grab one of those. You're going to put this in the little slot here at the bottom right of your controller. There we go. We're going to go ahead and do maintenance on those as well, by the way. There we go. By the way, I didn't mention this before, but make sure you don't place anything in front of the 9 blocks in front of the face of the turbine. If you put a torch here or a dual interface or something like that, it'll take a second. If I do update structure, suddenly it's incomplete structure. And then the moment that I take that away, update structure, there it's back. So make sure, because you can run into a situation, I know I did this before, where you put a torch down because you're trying to light the place up, and then suddenly it's incomplete and you don't know why. It actually does state that in the tooltip. It says air there, 3x3 area in front of the controller. So just wanted to make a note of that. Next thing we're going to do is put a dual interface right here. We're going to go ahead and connect this up with Fluix cable to our main IMI network. You're going to go up here to the dual interface. You can usually hide it from the terminal. I like to do that. And then switch to IMI dual interface GUI. And you're going to take benzene or whatever gas you're trying to burn. And we're going to drag that right here. And so that's how it's going to have access to it. It's going to import that from the dual interface. And so this is pretty much all put together now. So now I'm going to switch gears. We will do the redstone for this shortly. I've got a little area down here. But let's figure out how to get the actual redstone signal that we want before we actually bring it over here to the LGT. Alright, we're going to come back to our chest here. We're going to grab all of this stuff right here. And I'll show you how all this works. The first thing you're going to do is come over to your LSC, and you're going to take the 2 LV dynamo hatches. This could be any energy hatch, any dynamo hatch. This is merely something to put covers on, because if I try to put, see, we're going to end up putting redstone transmitters on here. You're going to need 2 redstone transmitter external. External is very important. And I need them to go like to the right and the left of the controller block. As you can see, I can't place that. There's no place to place this on the Lapotronic Supercapacitor casing. So what we're going to do is we're going to put a dynamo hatch there instead. Another dynamo hatch there. We can just point those upward. We don't care about the functionality of them. All we need them for is to place these right here. These redstone transmitter externals. We're going to place both of those right there. And now as you can see, I can shift right click and boom, there we go. Now, what are we going to be transmitting? Well, you're going to take this right here. You need 2 energy detector covers. You're going to place those on the controller block itself on the left and the right side, like so. And I like to think of the left as the lower bound of energy. Basically, when the energy of the battery gets below a certain number, we want the turbines to kick on. So we're going to decide that right now. And we're going to set this to, at the top here, you want EU stored. That's the amount that you want. And you want this to be inverted. So basically the redstone signal is going to be off unless it's below whatever value we put here. And so I'm going to put 1 billion, and you can actually type 1B, enter, and it'll fill out the value for you. So basically, whenever it gets below this value, redstone's going to kick on, it's going to turn on the turbines. Exactly what we want. And then for the high value, the other energy detector cover, again, we're going to do EU stored, and we're going to leave the redstone normal. So anything above this value, the redstone will kick on as well. And we want that to be somewhere near the top capacity of the battery, but not quite. We want a little bit of buffer room there. So we could do like 9.5 billion out of 10 billion. Sounds pretty good. And there we go. So we want to transmit these 2 redstone signals. That's going to help us turn it on and off. For the lower bound, you want to pick just some random number that is going to be solely for this purpose, so you never want to use this number anywhere else in your base. I'm going to choose like 8501, right? And then for the higher bound, we'll choose just the next number, the next integer, 8502. All right, perfect. So where I like to do this, I like to come down below to like a basement area, below the LSC. We're going to place down 2 frame boxes. This can be any type of frame box. I'm choosing black steel frame box. This could be aluminum frame box, titanium frame box, whatever you want. The sole purpose of this is to place redstone receivers. That's what's going to receive the redstone signal from the transmitters. Again, you want redstone receiver external, very important, not the internal. And we're going to just place both of those right there. And once again, we're going to set these, so shift right click, 8501 for our lower bound, and 8502 for our high bound. There we go. And this is probably not necessary, but I like to put the red alloy wire just on the face of it itself. You used to have to do that for some covers. Probably not necessary, but we'll do it anyway. Why not? Alright, so we're going to bring both of these around, and we're going to take something called an RS latch. This is basically a way of toggling the redstone signal based on the higher and lower bound redstone activating. And we're going to place that right there, this orientation facing outward this direction. And we're going to take our screwdriver, and we're going to shift right click with the screwdriver twice. This is just a normal GregTech screwdriver. So 1, 2, there we go, perfect. As you can see, our lower bound is on because we don't have any power in there yet, so it's below the value of 1 billion. And we're going to place the rest of our redstone like so. And you can see, actually, the redstone is coming out right now, so this is perfect. So the first time we connect this redstone signal, it's actually going to activate the LGT. So then you're going to put something called a wireless transmitter right there. This is what's going to deliver the redstone signal to the LGT itself. And let me put some of this stuff away. And you can right click this, and you can give it a value. And if you're worried about forgetting what the sort of wireless integer signal value is. You could type in here as well, but it's really nice to name this. So we'll do this RS, like LSC RS latch, and left click set name, and boom, there we go. And so when we set up our Redstone receiver, we should see this name that we can just click on. Be very, very nice. So that's basically done. Let's go back up to our chest of goodies up here. We're going to grab the rest of this stuff right here. I'm going to just get a little bit of dirt, or whatever block you need. This is the block that's underneath the main controller cover, right here. Yeah, the machine controller cover. Basically, we want to be able to activate this right here, this machine controller cover at the bottom of the controller block. Safe mode is generally a good practice if you generally want to do that. That way you're not like toggling it on and off infinitely. It's not burning through a bunch of stuff accidentally. Something goes wrong. What we're going to do is we're going to place our redstone receiver like so. And we're going to shift right click it twice with an empty hand. That's going to rotate it and bring it up there. And I'm not going to connect the redstone entirely yet, but basically you're going to run redstone like this underneath the blocks that are underneath both controller covers. So underneath the controller block itself, and then also, oh, I actually did that the wrong direction. This direction. Our input hatch with the fluid regulator and the machine controller cover. So this redstone will turn both of those on, which is exactly what we want. We can right click this. We can go ahead and double click our LSC RS latch. It's going to go ahead and set the value to 410. As you can see, that's on, but I don't want this to turn on quite yet, because we do need to do one more thing. Actually, a couple more things. We need to come back to this dynamo hatch. We actually need to get the power out of this. So let's deal with power now. You're going to take, in this case, you're going to take an extreme transformer. This is going to take 4 amps of EV and up transform them to 1 amp of IV. We're going to place that right there. And then you'll take a soft mallet, because normally it's taking 1 amp of IV and transforming it down to 4 amps of EV. We want the opposite. So we right click with a soft mallet. And if you look at the tooltip at the top, suddenly it says EV 4 amps input on 5 of the 6 sides. And then this one side that looks different from the rest, as you can see, is now the output. So 1 amp of IV output. That's exactly what we want. So we're going to take our wrench and we're going to point that downward. Then we're going to come back down here. You're going to want to take some cable that is IV amperage. Platinum cable. Usually you have a significant amount of platinum by now, so platinum cable is kind of throwaway. Make sure, yeah, max amperage 1. Be careful about the amount of amps that you're sending through this. And we're going to bring that down like so. And I like to, right around this point, take an insane transformer, and we're going to up transform this one more time. The reason for that is the higher the amperage of your power that you're basically traveling around the base, the less power loss you're going to have per block, because it's a higher packet amount. So losing 1 amp, or sorry, losing 1 EU over an 8,192 packet is not nearly as bad as losing it over a 2,048 packet, right? It's a smaller percentage decrease in the power. What we're going to do is we're going to place that right there. And again, we're going to take our soft mallet. We're going to transform up. Oops, hit the wrong thing. Right click that. There we go. And then again, 5 of the 6 inputs are going to be IV input. And then 1 of them is going to be LUV. As you can see right there, 1 amp LUV. Perfect. And then we're going to connect that up. There we go. All right. And let's come back over to our area here. We're going to take the rest of this stuff. We're going to get the power to the LSC and then show you how to get it out. For transporting LUV amperage around, vanadium gallium is a really good choice. Now in 2.8, the update that's coming soon, I believe this is being increased to 4 loss per block. But that doesn't sting nearly as bad when you're talking about a 32,000 plus EU packet of energy. So not nearly as bad. So we're going to take this, just keep an eye on your amperage. It's going to take 4 of these LGTs to make 1 amp of LUV. So just keep that in mind. as you do your setup. But we're going to basically bring this to the center right here, I suppose. It didn't have to be the center, but that's okay. Bring it over here. And then we're going to do a little bit of transformation to get it inside the LSC. So we're going to use an IV 64 amp energy hatch. This is basically the highest energy hatch that you have available at this particular part of the game in the IV era. And we're going to get rid of that. We're going to put our energy hatch in like so. And that's how we're going to get our energy inside the LSC. And so we can go ahead and hook this up. Actually, you don't want to hook that up because we have an LUV amp. We need to down transform that to IV. So I'm going to use an insane power transformer. This takes 16 amps of LUV and down transforms it to 64 amps IV. So we're going to place that right there. And yeah, our LUV input, as you can see on the tooltip, goes right there. So we will hook that up. Oops. Get my Vajra. There we go. Perfect. And so the other thing that we have to do is we have to get the power out of it and transport it around the base. So I'm going to take the same energy hatch, except it's a dynamo hatch, 64 amp IV. We're going to place that right there. And then we're going to do the same thing, except we are going to up transform this time. So use our soft mallet once again, and then your LUV output is going to be right there. Perfect. So we're going to bring this around like so, and then you would just take this basically wherever you need to in your base. And so that should be about it. I believe we have all the power hooked up. Let's take a look at our LSC, make sure everything's looking okay with it. And so we should see power go in here very, very soon. Actually, the moment that I hook up this redstone. But let's do it. Okay, I actually put the redstone in the wrong place once again. It's actually going to go right here instead. And now we should be getting benzene in there, like so. And there we go. Now we're generating power. And as you can see, yeah, we're only getting 13 liters in there per tick, which is the exact amount that we need. We can see at the tooltip that power is ramping up. We're above 1500. And so this is why you want these on, like they have some ramp up time. So essentially you only want to activate this the moment that you can run it for quite a while. That's why we do a lower bound here on the LSC of 1 billion. Because there's a bit of inefficiency involved in ramping these up and then ramping down, etc. There are some other power generations later in the game that just turn off and on, and it's just like a 0 and a 1 situation where it's either full generating power or nothing. The large Naquata reactor is a good example of that. But with these, you kind of have to, you know, set up this RS latch situation with it instead. And there we go. And we're at max power, 7,254 EU per tick. We take a look at this over here, and we are getting the power. Now, it looks like the energy is actually going somewhere. I think it's actually being stored in this cable at the moment, which is why we're not seeing anything in here at the moment. And there we go. So now those buffers are filled, and now we're getting some EU storage here. And so if we waited a little while, we would actually see that this would eventually turn off once we get past 1 billion EU per tick. I'm actually going to set these values lower, just so we can, or sorry, not per tick, but, you know, 1 billion EU stored. I'm actually going to set these values way lower, just so we can kind of test this out. I'm going to set this to 1 million instead for the lower bound. And then we'll set the upper bound to something like 10 million, right? And so once this number gets to 10 million, we actually should see that the system turns off and the RS latch. So basically, this redstone signal for the higher bound will turn on and activate this RS latch to turn the redstone off. And then once we got below 1 million, this would activate and turn the RS latch back on and turn on the LGTs once again. And there it goes. And it turned off. Perfect. Working perfectly. And so again, once we get below 1 million, this will activate again. And yeah, and that's the best way to get the most out of your LGTs. Make sure they don't have to ramp on and off all the time. Otherwise, you're just going to have a very inefficient setup. Anyway, I really hope that helped you. If you enjoyed the video, please give it a like and please subscribe to the channel for more tutorials, and we'll come at you with another one very, very soon. Until then, take care.